So we first calibrate the microscope using the ruler, and after that done, we use the microscope to measure the significant dimension of the LED and the laser diode.
We measured across our display 6 millimeters, which equivalates to 2044 pixels. That makes 1 pixel equal to 0.0029 millimeters. For the LED, we measured a length of 2.068 millimeters and a width of about 2.1, so about a square. And for our laser diode, we had a height of the post, which is our cavity length, about 1.7 millimeters.
Here, using the spectrometer to measure the spectrum of the LED here, and by using the Logger Pro software, we can measure the intensity versus the lambda graph, and by doing that we know the delta lambda, which is the width of the graph, is about 25 nanometers. Graph we found online, which is about like 30 nanometers for the width, compared to our experimental data, like they are pretty much close. So we use the 1000 Hz sine wave to modulate the LED source, and we rotate the LED to see the peak-to-peak voltage versus the rotation angle. And for the polarization ratio, we keep the LED stationary, and we rotate the polarizer to see the peak-to-peak voltage versus the rotation angle of the polarizer.
Here we see the graph for the LED of voltage versus degrees, and we see that it emits into a pretty narrow range of around -30 to 30 degrees, or a 60-degree total range, but for the laser diode, it's even narrower. When we rotated the polarizer for the LED, it became obvious that it was unpolarized, and so there is no ratio. However, when we did that for the laser diode, we found that there is a distinct relationship between polarization and voltage output. And the result is we can take a ratio of 48.75 when we take the highest value divided by the lowest value recorded. Alright guys, so for this part we took the integrating sphere and we put an LED at the input of it. And then we were able to adjust the current going through the LED and measure the output power. As a result, we were able to produce a graph for both a laser diode and the LED. Here we can see the graph of microwatts versus current, and we see that for the LED it's fully linear. However, for the laser diode, it starts off exponential and then grows linearly after 21 milliamps. We took the laser diode and input it into a spectrometer, and from there we measured the spectrum below the threshold and above the threshold, and we saw the output in our graphs, as you can see on the screen.